Hello, Pre-AP Pre-Calc scholars. We are going to look today at Skill 4, which is determining domain and range of a function. And I'm going to be splitting this into two videos so that I'm not talking as fast as I tried to do when I recorded them all as one. So I want to make sure that what we do in this lesson really makes sense. And this is a concept that can make sense as long as you allow yourself to think a little abstractly. But we're going to talk today about domain and range. So before we do that, let's define these words. So the domain of any function is the set of x values that a function can take on. And the range is going to just be the set of y values that a function takes on. Okay, so what we're going to do is we're going to first look at this from a graphical perspective. So I have four different graphs with various types of situations that occur. Some of these graphs are continuous, meaning that there are no gaps or holes or anything. And then some of these graphs are discontinuous at various places. And we're going to see how both of those play out when we're writing our domain and our range. All right, so when we think domain, remember we need to think x values. So when I think of domain, I think horizontally, okay? So when I think about the domain of this graph, so domain, I want you to be thinking, looking at the graph, scanning it left or right, okay? Now, the first thing I notice is at the very leftmost place here, I have a -4 with an open circle. Okay, so I'm going to put an open circle down here below at -4. And I'm going to scan this graph, and as I scan the graph, this graph is continuous along the entire graph starting at this value. So when I'm looking at this graph, I could continue to draw that without lifting my pencil. Now this arrow pointing down, notice that the graph has a slight curve. So it's going to go down and to the right. So when I'm defining the x values this function can take on, any x value that goes to the right of this -4 is allowed for our domain. So when we write this, we're going to write this, so this is -4, this is infinity, this represents all the x values that we're allowed to have for this function. Since -4 has an open circle and there's nothing to indicate that -4 is actually a value on this graph, we're going to use a parenthesis and we put -4 to infinity. Okay, the graph is continuous everywhere from -4 and everywhere to the right. So that is our domain. Okay. Now let's talk about the range. When we talk about range, we're talking about the y values. So I'm going to look at the y values. Clearly we could see that along the y values we have a definite stopping point up here at 5. And again, the graph is continuous and we have this arrow meaning it will forever go downward, so the graph will have a range that goes from -infinity up to 5. Now remember that 5 is not an actual point in the function, so we put a parenthesis there. Okay, and those are our interval notations to describe the domain and range for this function. Okay? All right, so now I'm going to talk about a more intricate graph. If we look at this next one, first of all, let's observe this arrow at the end here. So that means we're going to go forever up and to the left. So that piece means that there will be no beginning in terms of the domain. So I'm just going to draw an arrow to the left, pointing to -infinity. Things get really weird at the x value of 1. I have an open circle, another open circle, but I do have a filled in dot. So we are allowed to include 1 in our domain because there is a piece of the function defined there. And then this bottom graph goes forever to the right. So the domain, well, there's really no value of x that won't be anywhere on this graph. So we're going to say the domain is negative infinity to infinity, meaning all real numbers will be a part of our domain here. Now, as for the range is where we start to see some funky things happening. For the range, clearly, looking at the range, when I look at this arrow pointing upward, we're going to have no bound up here at positive infinity. We have an open circle at 2. Okay, so that there's no piece of the graph that is actually defined at 2. Now, at 1 and at 0, I can see there is no graph anywhere. So we don't have anything from 0. Well, really anything that's above negative. Well, actually, I lied. Sorry. Ignore me because I didn't see this arrow over here. This arrow goes forever upward. So guess what? We actually do have a point at 2. Because even though we see the open circle right here, eventually we will hit a value where the y is 2 because of this arrow. So actually, our range is also negative infinity to infinity. Okay, and the only reason that worked out is because we have these arrows, this arrow right here. If we didn't have that arrow there, then we would have had what I was about to describe, but I didn't notice that arrow at first. All right, so domain range for this, every real number can be defined somewhere on this graph. All right, now we're going to take a look at 2 more intricate graphs here. Again, we'll start with domain. When I look at domain, notice this arrow here. So this is going forever down and to the left. So there is no beginning in terms of domain. Now the graph definitely does not continue on to the right, and there is no arrow over here. There's no arrows. So we definitely have an ending point at 5. Okay, so there are, and also if you look here at negative 1, there is no value that has a negative 1 in the domain. Okay? So I'm going to redraw this so that we see that. All right, so when I write my domain here, there are 2 pieces. We have this piece here that goes from negative infinity to negative 1. We have open circles in these locations at negative 1 and no piece of the graph that actually hits negative 1 anywhere for an x value. But then we have this piece over here that includes everything from the right of negative 1 over to 5. So we're going to have negative 1 to 5. But again, the open circles here mean that we are not going to include the endpoints. Okay? That's going to be our domain. So domain, we're looking left to right. Now let's talk about range. On our range, okay, we definitely have an open circle right here. It looks like it's about 3.5, so I'm going to call it 3.5. That's going to be our highest value. There's no arrow over here, so we don't have anything that continues on there. But we have this arrow that goes forever downward like this, so there will be no bottom value. So anything below 3.5 will be the range. So negative infinity up to 3.5 is going to be our range. That is really ugly. Let me just fix that. Okay. All right, and then this graph over here, the 4th one, let's talk about its domain. For the domain, I see an open circle here at negative 5. When I'm looking here, I do see an open circle at negative 1, but I also see a filled in circle. So I would keep continuing on. We're fine here. And we have this arrow that's going up and to the right, so there will be no ending value for my y's. Okay, so my domain is just -5, whoa, -5 to infinity. Okay. Now, when we talk about the range, let's start, we definitely have a bottommost value here at -3, and this time it's actually a point because we don't have an open circle. But then we have this arrow that's pointing upward, so any y value from this point on is part of our range. So we're going to write our range. This time we use a bracket for our -3, and we go off to infinity. Okay, so that's how we're going to find the domain and range from graphs. Okay, so it's just looking at it horizontally and looking at it vertically and determining which values x is first for domain that a graph can take on. And then same idea with the range, looking at y values. Okay, so I'm going to stop this video here so that you can practice this part of the skill. And then after you've practiced this skill, then we're going to continue with the second video that will talk about this from a function perspective.